This video we are going to cover page object model principles. Let's get right to it. Let's get started by answering the following question. What is page object model? Simply put, page object model is a design pattern in automation testing. It is mainly used to separate the test code from the web UI elements, making our test more modular and easy to maintain. It actually creates an object repo for web UI element, improving code reusability and maintainability, which is extremely essential. And the end product is each page of our application will have its own corresponding page class that contains the elements and methods to interact with that given page. The goal of this structure is an improved code reusability and maintainability, making our application portable and easy to maintain, especially in large-scale projects. Now let's take a moment to cover the key principle of page object model in order to understand exactly what we need to include while following this methodology. First things first, separation of concerns, which is mainly isolating test logic from UI structure. This means that the test script should only focus on the test scenarios and not on how to locate or interact with the UI elements. Then we have modularity, which can be accomplished by encapsulating page-specific operations in separate classes, which means each page class will represent a single page of the application and it will contain the elements and methods specific to that particular page. Finally, maintainability, which means that when there is a change in the user interface, we only need to update the page classes and the changes will be reflected across all our test scripts that choose those particular page classes. To better understand how we can leverage the power of page object model, we need to dive a little bit deeper into the benefits of this methodology. One of the main benefits of page object model is reducing code duplications by simply reusing the page classes across multiple test scripts and eliminating any duplicate code. In addition, we also benefit from enhanced readability, which means that our test scripts will become more readable and easier to understand as they are written in a high-level language that describe the test scenarios rather than the implementation details that can be a little bit tricky to pick up. We also benefit from simplifying maintenance. In other words, when the UI changes, we only need to update the page classes, making maintenance easier and more efficient across our test scripts. In fact, page classes can be reused across different test scripts, promoting code reuse and reducing the overall code base that our team will have to output. Now we need to understand what are the steps that are necessary in the implementation process of the page object model in WebdriverIO. We start our process by creating a base class. This class will contain common methods and properties that can be used across all our page classes. The next step would be to create a specific page class, which means that each page class will extend the base class and will contain the elements and methods that are specific to that page. Then we have to use the page classes in the test script by simply instantiating the page classes and interact with the web user interface. To understand exactly how we can implement a page object model in our test cases, let us go ahead and cover a quick example of a page class. We start by creating our login page that will extend the base page. How do we do that? Class login page extends base page. Then we use the get username that will return the username. How does it work? Get username, open close parentheses, return username. Then we do the same to get password. How can we do that? Get password, open close rectangular brackets, return password. Then we define the login method that will take as argument the username and password using the following statement: login, open close parentheses, username, comma, password. Then we use the this operator to set the value of the username using the following statement: this.username.setValue, open close parentheses, username. Then we do the same to set the password using the following statement: this.password.setValue, open close parentheses, password. After that, we simply click on the login button by using the following statement: browser.click, open close parentheses, and then we provide the ID of the login button. In this case, the ID is going to be hashtag login dash button. Once we are done with the implementation of our login method, we close the method definition using curly brackets. Then we close the class definition using another curly brackets. To understand exactly how we can leverage our page object that we just created together, we need to understand exactly how we can use the page object in a test script. We start the process by using the describe method that will describe the set of test cases that we're going to cover. How can we do that? Describe, open parentheses, open close single quotes, login test, and then we use the arrow operator followed by the curly brackets in order to start defining our implementation. Then we use the it method that will describe our test case. In this case, our test case would be should login with valid credentials. Then we call the open method using the following statement: login page.open, open close parentheses /login. Then we simply call in the login method that will enable us to log into the given page. How can we do that? Login page.login, open close parentheses, user, pass. So we are mainly providing the username, which is user, and the password, which is pass. Then after that, we use the expect method to double check if we actually logged in successfully. How do we do it? Expect, open close parentheses, browser.getURL.toBe, open close parentheses, open close single quotes, /dashboard. So we are checking if we move to the dashboard page, which will signify that our login process was done successfully. Then we close our method definition using curly brackets and parentheses, and we finalize our implementation using an additional curly brackets and parentheses. To fully understand how you can use the page objects model in your project, it is a great idea to cover the best practices that should be followed in order to benefit from this technology fully. Initially speaking, we have to use descriptive names for methods and variables. This will enable our team to improve the readability of our code and test cases. In addition, we have to avoid hard coding using configuration files. This can be done by simply storing configuration data in separate files to keep our code clean and maintainable. Another best practice to use is to keep one method per class. This is a great way to specify the limitation of your methods, which means that each method will have a single responsibility, making the code easy to understand and easy to maintain by our team. Last but not least, we have to follow a standard layout for all our pages, which means we have to implement consistency in the layout of our page classes, which will enable us to maintain the code base and understand the structure of our project across different test cases and test scenarios. Understanding the best practices is a great way to leverage the full potential of page object model. However, we also have to be aware of common pitfalls, such as overcomplicating page classes, which means we have to keep our page classes simple and focus on their responsibilities. We also have to avoid neglecting maintenance, and the best way to avoid neglecting maintenance is to regularly update our page classes to reflect any changes in the user interface. Another pitfall to keep in mind is to ignore code reviews. And to counter this pitfall, we can simply conduct code reviews to ensure the quality and maintainability of our page classes is always up to date and up to our team standards. Please be aware of skipping documentation, and this is a critical pitfall to avoid. The way to do that is by simply documenting all your page classes and methods to help others in your team understand exactly the purpose of every method and class and their usage.